In this section, we explore the methodology behind building an intelligent AI-powered mental health chatbot. The system is designed using advanced natural language processing, machine learning, and deep learning techniques to understand user emotions and generate meaningful responses. The motivation behind this system arises from the growing gap in mental health care services worldwide. Traditional mental health care systems often face significant challenges, including limited accessibility, high costs, long waiting times, and social stigma. Because of these barriers, many individuals hesitate to seek help or are unable to receive timely support. This highlights the urgent need for intelligent, scalable, and easily accessible solutions. AI-powered chatbots address these challenges by providing instant, cost-effective, and stigma-free support. They allow users to express their thoughts freely and receive immediate guidance without fear of judgment. As a result, AI plays a crucial role in bridging the mental health gap and making support available to everyone, anytime and anywhere. Initially, traditional machine learning models such as support vector machines, or SVM, were widely used for sentiment classification. SVM works by identifying an optimal decision boundary that separates different classes of data, making it effective for structured and clearly defined datasets. However, when applied to real-world text and emotional data, SVM begins to show its limitations. It struggles to understand complex emotional patterns and fails to capture deeper contextual meaning. In conversations, this makes it less effective for applications like mental health chatbots, where understanding subtle emotions is critical. These limitations highlight the need for more advanced approaches in sentiment analysis. To overcome the limitations of traditional models like SVM, more advanced deep learning approaches such as convolutional neural networks, or CNN, are introduced. CNN models are capable of automatically extracting meaningful features from text data, allowing them to understand complex patterns in human language. Unlike traditional models, CNN can capture contextual information and subtle emotional variations more effectively. This enables the system to accurately classify sentiments such as positive, neutral, or negative, even in complex conversational data. As a result, CNN significantly improves accuracy and performance, making it highly suitable for real-world applications like mental health chatbots. The proposed system architecture is designed as an end-to-end intelligent pipeline that enables effective interaction between the user and the AI chatbot. The process begins with user input, where the system receives text in natural language form. This input is then processed using natural language processing techniques to understand its meaning and context. Next, the processed data is passed to the sentiment analysis module, where advanced models analyze the emotional tone of the message, identifying whether the user is experiencing positive, negative, or neutral emotions. Based on this analysis, the response generation module creates a context-aware and meaningful reply tailored to the user's emotional state. Finally, the system delivers the output in a conversational format, ensuring a smooth, human-like interaction. This architecture forms the backbone of an effective AI-driven mental health chatbot. The chatbot architecture begins with understanding the user's input. When a user sends a message, the system first performs intent classification to identify the purpose behind the query, for example, whether the user is asking for help, expressing emotions, or seeking guidance. Next, entity recognition is applied to extract key information from the input, such as time, context, or specific concerns. This step is crucial, as it enables the system to accurately interpret the user's message and prepare it for further processing. Once the user input is understood, the information is passed to the back-end systems for further processing. This includes APIs, databases, and intelligent models that help generate the most relevant response. The system then uses dialogue management techniques to maintain context and ensure the conversation flows naturally. Finally, a meaningful and context-aware response is generated and delivered back to the user. This entire process enables the chatbot to provide accurate, personalized, and human-like interactions. User input is pre-processed using techniques such as tokenization, stop word removal, and lemmatization. This ensures that the model understands the core meaning of the text. The chatbot is trained using structured datasets containing conversational patterns and emotional labels. This helps the system learn how to respond effectively in real-world scenarios. Convolutional neural networks, or CNNs, play a crucial role in sentiment analysis by enabling deep understanding of textual data. The process begins with input text, which is first converted into numerical representations through embedding techniques. These embeddings capture the semantic meaning of words in a structured format. Next, convolutional layers apply multiple filters to extract important features and patterns from the text. This helps the model identify key emotional signals present in the input. Following this, pooling layers reduce the dimensionality of the data while retaining the most relevant information, improving efficiency and performance. Finally, the processed features are passed to the output layer, where the system classifies emotions such as anxiety, depression, or stress with high accuracy. This deep learning approach allows CNN to capture both context and subtle emotional variations, making it highly effective for real-world mental health applications. The detected emotion is integrated into the chatbot system, allowing it to generate personalized and empathetic responses. The system workflow follows a structured, step-by-step process to ensure accurate and intelligent responses. It begins with user input, where the system receives text in natural language form. This input is then passed through the pre-processing stage, where techniques such as tokenization, cleaning, and normalization are applied to prepare the data for analysis. Next, the processed text is fed into the sentiment classification module, powered by CNN, which identifies the underlying emotion, such as anxiety, stress, or depression. Based on this emotional understanding, the system generates a context-aware and meaningful response tailored to the user's needs. Finally, the response is delivered to the user, completing a smooth and human-like interaction cycle. This workflow ensures that every interaction is intelligent, responsive, and emotionally aware. The system is evaluated using multiple datasets and performance metrics such as accuracy, precision, and loss. In order to evaluate the performance of the proposed model, a comparative analysis was conducted between traditional SVM and the CNN-based approach. The results clearly demonstrate that CNN significantly outperforms SVM across multiple evaluation metrics. In terms of accuracy, CNN achieves higher precision in detecting complex emotional patterns within text data. Additionally, CNN shows better performance in reducing loss and improving generalization, making it more reliable for real-world applications. While SVM works well for simpler datasets, it lacks the ability to capture deep contextual information, which is essential in sentiment analysis. Therefore, CNN proves to be a more efficient and scalable solution for building intelligent and emotion-aware chatbot systems. The proposed model achieves higher accuracy and better emotional understanding, improving chatbot effectiveness. This research presents an advanced AI-powered chatbot named TED, designed specifically for mental health support. The chatbot is capable of understanding user emotions by analyzing textual input and identifying underlying sentiments such as anxiety, stress, or depression. Based on this emotional understanding, TED generates personalized and context-aware responses, ensuring meaningful and empathetic interaction with users. With an accuracy of up to 98%, the system demonstrates high reliability and effectiveness in real-world conversational scenarios. This highlights the potential of AI-driven solutions in transforming mental health care by making support more accessible, responsive, and user-friendly. The future of AI chatbots lies in building more intelligent, adaptive, and human-like systems. One of the key advancements is the integration of meta-learning techniques, which enable models to learn and adapt quickly from new data with minimal retraining. In addition, the use of multimodal data, such as voice, facial expressions, and behavioral patterns, will significantly enhance the system's ability to understand human emotions more accurately. By combining these technologies, future AI systems will be able to provide deeper emotional insights and more personalized support. This will not only improve the effectiveness of chatbot interactions but also expand their role in real-world mental health care applications. Ultimately, AI chatbots will evolve into intelligent companions capable of delivering continuous, empathetic, and proactive support. In conclusion, AI-powered chatbots are transforming the landscape of mental health care by making support more accessible, scalable, and intelligent. By leveraging advanced technologies such as natural language processing and deep learning, these systems are capable of understanding human emotions and delivering meaningful, context-aware responses. They bridge the gap between individuals and mental health support, offering timely assistance without barriers such as cost, availability, or stigma. As AI continues to evolve, it holds the potential to revolutionize mental health care by providing continuous, personalized, and empathetic support to users worldwide. This marks a significant step toward a future where intelligent systems enhance human well-being at a global scale. As we move forward, artificial intelligence continues to reshape the future of mental health care. AI-powered chatbots are not only improving accessibility but also enabling intelligent, real-time emotional support for users across the globe. With advancements in deep learning and adaptive systems, these technologies are becoming more accurate, responsive, and human-centric. This marks the beginning of a new era where technology and empathy come together to create smarter and more accessible mental health solutions. Stay connected for more insights into the world of AI and innovation. Thank you.